Hello, my name is Y2BlockC and this is my video evidence for the blueprinting objective of BlockC Year 2. This block I've been developing over 100 standalone blueprints, and for this reason this video will only focus on the 3 most challenging ones. So let's get started. The first blueprint that I'm going to showcase is the one for the rewindable object. I'll showcase their functionalities really quickly. What I can do is press Q to start recording time, and from that moment onwards, everything that happens to these blue cubes will be recorded. I can press right mouse button to rewind them back in time. So let's see how they work. Every tick, I will check if the player is playing with a first-person character or a third-person character, as currently the player is able to switch between the two. And depending on which one is using, I set the reference for the character and I check if it is recording. Now, depending on this, two things can happen, and this is the actual function for the time rewind. So, if we are recording, we start with checking if the right mouse button is down. That means we are checking if the player is trying to rewind time or if he is just recording it. If the player is just recording time, then we will store the transform of the cubes in an array and save it to access it later on. But also, as you can see here, we will store every linear velocity and angular velocity of every cube in another array to access it later on. If instead the player is indeed pressing right mouse button, what we will do is we will get the last index of the array and we will set the transform of that cube to the previous one, removing that index from the array. And the same thing goes for the linear and angular velocity here, making sure that we remove the last index from the array. If, to conclude, instead the player is not recording, that is the execute pin number 2, then we make sure that we clear the previously filled in array so we can save memory. For the third person character is the same exact thing, with the only difference that we're going to be accessing another boolean that is set in the third person character to check if he is recording or not, and if he is pressing the right mouse button, but the logic for it is exactly the same. On to the next one, the stages bullet. I'll showcase the functionality really quickly. As you can see, the one that I'm shooting is our normal bullet, but if I use the stages one, all the physics objects inside this radius are going to be frozen in time. This also affects other bullets. So how does it work? At the beginning we do a double collision check, as sometimes because of the velocity of the bullet, the collision might be misread by the engine. So we both check hit and overlap. On overlap we check that the red value is not the character or the stages bullet itself, as sometimes Unreal can misread this value. While both on hit and overlap, we check that what we're hitting is not a checkpoint. If we're clear from all this possibility, then we want the bullet to explode. At this point, what we do is stop movement immediately. That will make the bullet freeze in position, while activating a particle system for the explosion, while also activating a radius damage to the destructible mesh that the bullet is made of. At this point we activate physics to make sure that the destructible mesh also has a realistic reaction to the impact. Then we set the gravity scale of the projectile movement to 0 to make sure that the bullet that is frozen in position doesn't just fall down. Once that is done, we set the radius visibility to true, together with the possibility for it to generate overlap events. As a matter of fact, as you can see in the viewport, the radius is always there, but is invisible and is not generating overlap events. So we just activate it whenever the bullet explodes. Once that is done, we call in the freeze event. This is the freeze event, and as you can see, the first thing that the freeze event is going to do is wait until the duration of the stages is finished. This is because the logic for the freezing itself is instead fired by the overlap of the radius that has just been enabled to overlap other actors. So let's see that one first. On overlap, the radius will check that it's not overlapping with the stasis bullets itself, the character, or another first-person projectile. If indeed the radius is overlapping with the first-person projectile, we're going to store the reference to the projectile plus its velocity into arrays to make sure that we can access it after, and then fire off the function bullet freeze. What the bullet freeze function does is, for each of the reference bullets that we registered in the array, we stop the movement immediately and set the gravity scale to 0 to make sure that the bullet freezes in position and doesn't start falling because of the gravity. But at the same time, access the index of each element of the array and input it in the bullet velocity array to make sure that once we're going to reapply velocities, the right velocities are going to be applied to the right bullet. Back to the overlap function for the radius. We now know that our radius is overlapping with something. We just saw what happens if that something is a bullet. Now let's see what happens if the gas fails, and as a result what we're overlapping with is going to be a physics actor. In that case, we're going to add a reference of that actor to an array together with its velocity and set simulate physics to false to make sure that all physics simulations stop in that very instance. And at this point, we want to go back to our freeze function. The freeze function has been fired together with the activation of the radius. So at this point, once the stasis duration is complete, we activate both release bullets and unfreeze. Two functions are really similar, but they serve two really different purposes. The first one, release bullets, is going to get all the elements of the overlapping projectile array and apply the velocities that we stored previously, and then destroy our blueprint to make sure that the radius disappeared and everything goes back to normal. Similarly enough, the unfreeze blueprint instead is going to get all the elements of the array of the physics actor, set simulate physics to true, and then apply all the velocities to the correct elements of the array, and at the end it will destroy the blueprint. And now into the final of these three blueprints, the checkpoint system. I'm just going to showcase the functionality of it. As you can see, there are these cubes on the ground. This one is green. If I walk on top of one of them, it says checkpoint saved. And if I now die, I'm going to respawn just at the cube that I just touched. Now this works as follows. As you can see from the viewport, the checkpoint system has a collider around it, and as soon as something overlaps with that collider, we're going to check if that something is a first or a third person character, depending on what the player is using at the moment. Depending on that, we're going to set the spawn transform variable to the current transform of the player. Then we're going to give visual feedback to the player of the fact that the checkpoint has been activated by changing the color of the mesh from red to green and giving a string confirming the checkpoint is saved, and finally we're going to create or overwrite, if already existing, a save game file. Now, the tricky part with this is that this node actually creates an actual save file on the drive of the player, and this is quite tricky to get right. We're going to create a new save game object, then check that that save game is the same as our save blueprint, and that is correct. We're going to set our spawn transform as the save spawn transform inside our save game slot. What's positive about the save game file is that, differently from everything else, the data stored in the save game files will not get reset when we reset the level. Now let's take a look at our save game. As you can see, is a blueprint class in itself, and everything we have in it is just a variable that is a transform that is called saved spawn transform. That is the one that we save here. The very last step to get this to work is in the level blueprint. Here what we do is on begin play we check if a save game already exists. If there is already a save game, what we do is we destroy the currently existing actor in the world. Then we load the save game file, and here we set the transform of a newly spawned first person character to the one saved in the save game file, and then we possess the character. If you set the recent any save game file, that means that it's the first time the player launches the application on his computer, then we get the first person character, that is the first person character that we physically placed in the world. We get its transform and set it as a new variable called first spawn. Then we destroy the actor and we respawn a new one with the first spawn transform. This workaround allows us to make sure that even without a save game file, the player will still be able to spawn wherever we decided him to spawn. Now, I think it's worth mentioning that even if these blueprints might not seem as complicated as, for example, our first-person character that doesn't even fit anymore in the blueprint graph, or the spline-based minecart, the complexity of this blueprint came from the fact that there are a multitude of factors that could have made them go wrong, and figure out the correct way to make them work well and well together was the trickiest part. Also, all of these blueprints touched areas that I never touched before, so they were really interesting to dive into and explore.